Today we're going to go over how to create toolpaths, and we're going to be using the Titan 1M. You'll need to open this file, and in your SolidWorks across the top you should see CAM. Don't use the SolidWorks CAM or SolidWorks CAM TBM. You want CAM. This is the HSM from Autodesk, and that's what we'll be using. Now, in your design tree here, we're going to scroll clear to the right, and we're going to find our CAM manager, and this is going to be our new design tree for toolpaths. When you first start out, you will need to use a job, and inside the job you will be creating the size of your material, and you're going to set up your work coordinate system and choosing your 0 point. So to start off with, you can give it a name. You can name the job whatever you'd like, or you can just leave it blank. Make sure your model is set to the Titan 1M just by clicking on it. And now your stock size. Right now this is set for a relative size box. It's going off of the actual model. We want to change this to a fixed size box. This material should fit your material that you're going to be holding in your hand that you'll be sticking in the mill. So you will actually need to measure that material or know what that is. And this is something you can come back and change later. So right now I'm going to give us a little bit of leeway here. We're going to say it's 5 inches long and 2 inches wide and 3/4 of an inch thick. And I'm going to come down, and you can change these, but normally you'd want to leave these centered in the stock. There may be times you may want to change these, but for this project we're just going to leave everything centered. We're going to come down to your world coordinate system, or your work coordinate system, and you're going to choose where your 0 point's at. What we want to do is have the 0 point up in this corner. It is much easier to locate in the mill than something in the center. So to do that, we are going to choose top corner number 3. We want to make sure our X and Y are going, our X is the red, we should be going left and right. Our Y should look like it's going up and down in this view, and our Z is going to be coming straight out at us. And if everything looks good there, we'll just come down and we'll hit our green check mark. So we now have a job here. Now, when it comes to your milling, your tool paths, you have some different options. You have drilling, you have milling, 2D milling. These are the two ones that you're going to be really concerned about. Under 2D milling, you have facing, adaptive clearing, pocket, contour, slot, thread, so on. Most of the things that you are going to be either doing will either be a face, a pocket, or a contour. Sometimes you might use a slot, but most of the things you'll be doing will be a contour, pocket, or a face. A face is when you are actually going to make the entire material thinner. That's going to remove a lot of material very quickly, and it's going to give a pretty rough surface. You only want to use this if you have to make something thinner for the most part. A pocket would do an area like inside of here, something that doesn't go all the way through. The contour follows a shape. It goes around the object. The other one is drilling. So that's going to be the one you use for drilling holes. And I like to always start off with drilling. And when drilling comes up, we need to choose, this is our palette for drilling. We have our tool. We actually have to pick a tool. So we go to our library. And you might have a robotics toolpath. If not, you can just go into all tools, and you can go into by type, and I'm drilling, so I'm going to find the drills, any drill, and our drills have changed. Now, for our holes here, let's just say we want to do a number 21 drill bit. we'll just type in number 21. And this will give us a bunch of 21 drill bits. What the difference on these are, a lot of them is in the length, but for what we're doing, we just need to pick one. So we're going to click select. Your feed and speeds, you do need to pay attention to this. If you go too fast on your spindle speed and too slow on your speed, you're going to dull your bit out real quickly. But for the most part, for what we're doing here, we're going to do 3120 for our spindle speed. Then our plunge feed rate, we're going to change this to 10. Our retract feed rate is when it comes back out. We can have that set for 40. Don't worry about the surface speed. That will change when you change the plunge feed rate. Okay. Our next thing is going to be picking our geometry tab. We have to come through and pick our holes that we want to drill. So we can click that hole and we can check the same diameter, and it will automatically pick every hole in this object that has the same diameter as this hole here. That is useful if all the holes are the same depth. If they're not the same depth, you can check this off and you can just come in and select the holes that you want to do. I'm going to select same diameter. Our next tab is the heights. How deep do you want this drill bit to go through? Is it going all the way through the project? Is it only going partial the way through? When we pay attention to our things here, the main ones is the top and the bottom location. So this is coming from the whole top. We may want to change this from model top. So it's coming from the materials that you have in your hand going through. And we can say from whole bottom. And if you want, you can check the drill tip so it goes clear through the project, and you can tell it how far down you want it to go. I'll normally say like 0.05. So just a little bit of the bottom of the drill bit goes through the object. And our next thing is our passes, and we're going to change from drilling rapid out to down to deep drilling full retract. What this will do, will allow a pecking motion where the drill bit goes in and out, so it allows the drill bit to clear the material out of the hole and helps to keep the bit from breaking. You don't have to make any changes here. We're going to click the check mark. So you now have a toolpath for drilling. So now I want to do a pocket for the inside of this area. So we can come into our 2D milling and we're going to choose pocket. And our design tree is going to change again. Now we're in the pocket area. And again, we have to pick our tool. So we have to go to our tool library. Now this time we are going to be doing a flat end mill. So we're going to go into our material, or by type. We're going to choose flat mill, and we're going to choose a 1/4 inch flat end mill. Select. And again, our feeds and speeds, there's a lot more of them this time. So our spindle speed here, again, is going to be 3120. And we're going to come down to our cutting feed rate. We're going to change this to about 20. This is 20 inches a minute. Our lead in, this is how the flat end mill is going to come into the material. We'll change this to 20. Our lead out will change to 20. And our ramp feed rate will change to 20. And our plunge feed rate, we're going to change to 10. Now, let's explain some of these. Our spindle speed is how fast the bit's spinning. Our cutting feed rate is how fast is the bit going to move through here. If you go too fast, you'll snap your bit. These numbers are a fairly decent number. Your lead in and your lead outs is how fast is the bit going to go in and come out of the material. Your ramp feed rate is if you go in at an angle, how much of this is going to come out and how fast. And then your plunge feed rate is when the material or the bit goes into the material. We don't want to go too fast. We have to have the material or the bit a chance to cut the material as it's going in. Now our next thing is we have to pick our material or our pocket area. Now on this, I'm just going to choose this face right here. It's the bottom of the pocket. Alright, you need to pay attention to your arrow. If your arrow's on the outside, it's going to cut the material away from the outside. If it's on the inside, it's going to cut the material on the inside. And for our top, for our heights, again, we want to be from stock top, and we're going to go to contour. And we're going to go to passes. Now, we're going to check on both ways. We're going to check off stock to leave. We don't want any material left over when we're done. And we're going to choose multiple depths. You have to pick this, or else that bit is going to try to do all this material in one pass, and you will break your bit. So we're going to change this to 0.04. And then our last thing here is going to be our lead ins and leads out. Okay. And our ramping position is a helix, so it's going to make a little circle coming down into it. If all those things look good, we'll just click OK. And now we have a toolpath that comes through. This little circle area here is where the material is going to be removed. Now looking at our design here, we also have a little platform here that I did not pick, so I can come back in, I can right click, choose edit on our pocket, and I can come back to our geometry tab, and I can come in and click this area as well and hit the reverse button on that so it stays on the inside. And now it's also picked this area here, so you can go back in and edit these if you need to make changes to them. If you need to come back and choose a different tool, I can come back over here, click on my tool library, go to my robotics, and I can choose what I want to pick here, so flat end mill, and hit my check mark. And now we have our toolpath. Now the last thing we have is a contour that's going to go around us. So our material is, remember, our material is larger than what we have. So we're going to do a 2D contour. And I'm going to, it's already picking the 1/4 inch flat end mill because that's what I used last. My feed and speeds are already taken care of because it's based off tool number 5, what I've already picked. I need to come into my geometry tab, and I'm going to choose my bottom line, not a face, so we're going to delete that. So I'm picking my line around the bottom. Now my heights, now here's where we're going to have to pay attention to, because if I mill this all the way out and this is sitting inside of our vise, our bit is going to crash into our vise. So we are going to change the bottom of this. We're going to bring it up about a 1/4 inch so we do not crash into our vise. Okay, so it's not going to mill all the way through on this design here. Again, we have to check multiple depths. This is a must. You have to have multiple depths checked, and make sure stock to leave is on checked. And we will click OK. So now our toolpath is not going clear through. If I did not change that, let's show you. We'll go back to edit. We'll go back into our heights. And if I left this as 0, all of this gets taken out when it mills it. And if our vise is clamped in here, then we will run into our vise, break our bit, damage our vise. So we don't want that to happen. So again, we're going to set this for 0.25. So we're bringing the bottom of our toolpaths up 1/4 inch. So when you clamp this into the vise, you're going to have to be about 1/8 of an inch above the bottom part of your material. And that is our toolpaths for this project. Now, to create the actual toolpath for the machine, here's what you will need to do next. You will need to come up and generate, click on the job, and you're going to tell it to post-process. The post-process is this window here, and you will need to choose the Tormach Path Pilot, and it should be in the post-processors already. You're going to give it an output folder. Where are you saving it to? So you have to know where you save your stuff. You're going to give it a name, alright, and I'm going to click Post. Now, this, if you show the post-processing, this is your actual program here. This here will tell you what tools you're using. So I'm using Tool 1 and Tool 5. And my very first tool is Tool 1, which it tells me it is a drill bit. And then it's going to do my drilling. And I'm going to come down to my pocket. And that tells me it's Tool 5. And Tool 5 is a 1/4 inch flat end mill. So this is what we need to take to the mill. If you want to simulate this object, you can click Simulate. Let's turn off our toolpaths so you don't see them. Let's show our stock. And we're going to slow this down just a little bit. We're going to hit play. And this is our drill bit. You can see our drill bit going in. And this is the pecking motion where it goes in and out. We'll speed this up a little bit. And then this is our 1/4 inch end mill that goes in and hollows out the inside. And then we have the outside. Now again, this should leave some material around the bottom. Now, we do have an issue. What is happening right here? We don't like how that looks, so we got to go back in and check that area. So we're going to come back into our pocket, and we're going to edit our pocket again. And we're going to come into our geometry, our face number 2. Let us try to reverse this. And now let's simulate. Simulation is a useful tool for you. It saves a lot of material. You can see where your mistakes are at, and we still have an issue with this area. So there's multiple ways we can deal with this. We can come back into our contour, or we can just do another contour. And let us also pick, not that one. We'll also pick that. And you can see we're on the wrong side, so we need to reverse that. And we'll simulate one more time. And let's show our stock. So, but we'll have to play around with this. This will clean up. We just have to make some minor adjustments, but for the most part you have gotten your toolpaths figured out. Any changes that you would have made since your first export of the toolpath, you would have to generate the toolpath again, and do your post process and resave it, and then that will make your new G code for you again with the changes that you have made.